All right, well, I think I am gonna get rolling here. So thanks everybody who's been able to make it. As you know, we try to put these on monthly, and we'll be coming out with our schedule for next year. And so that'll be emailed out to you, give you an idea of what we're doing in the first quarter of next year. Um, for any of you who aren't aware, we're also putting on a ongoing course on sample system design. We're at session 6 of it now, but the recorded sessions are available on our website. And so if you want to go back and see any of the historical ones or join us for any of the new ones, registration is also done, can be done through our site as well. So I often do these webinars and talk either about specific applications that we've been selling analyzers into. So we've done some recently on gas plant optimization and on crude oil blending. And what I want to talk about this week is some of the unique sample system components that Insight has developed and manufactures and sells. So I apologize, this one might seem a little bit more commercial because everything I'm going to talk about is product that we build and sell. But I will try to give you some idea of what the technical benefits of those are and the applications they get used in as well. So I usually start this off with a little bit about Insight, and like I say, we are not your typical distribution type company. We tend to be very technically focused rather than sales focused. We like to see that or consider that we put ourselves into a bit of a thought leadership type position by providing a lot of active training courses and materials. We're doing the sample system course. We do regular webinars. If you're with an engineering company or an end user, we're always happy to come out and do lunch and learns. We try to focus the business around on understanding customers' processes, their applications, why they might need a measurement solution, and then help to develop that measurement solution and capabilities. We don't carry an awful lot of product lines. We like to be experts in what we do, not generalists. My background is as a spectroscopist, and so most of the equipment we sell is spectroscopy based because we feel like we know that really well. We like to get actively involved with our customers. And so our approach to selling and to business development is to basically, we like to get involved with people that have a question. Kind of go, well, how can I make this measurement? Or how can I improve how this process runs? Or how can I monitor this better? And so we like to get involved with people that are looking for new solutions, interact with them, talk about what their problems are, what they're trying to solve, what the value of the measurement would be, innovate and think about ways we could possibly try to solve it, inform them and give them a number of options, work together with them to figure out what might be the best option to it, invent or develop things as we need to. And so what I'm going to talk to you today about is a lot of the things that we've developed as we've gone through this process. And then develop that solution, integrate it if it needs other equipment around it, implement it at the site, and hopefully by the end of it, that customer who came in leaves with some new capabilities. And so that's kind of the approach we like to take to the sales cycle, if you like. So I'll start off usually by mentioning that we do quite a bit of systems integration work as well. So although we like to say that we're analyzer centric and sample system centric, we really do focus on trying to provide a complete solution. So we have full systems integration capabilities here. Can build full analyzer buildings. We can design custom sample systems. We'll do process analyzer integration, where we add sample systems onto the analyzers. We will build full PLC-based systems and add automation around it. Integrate that all into a building and deliver the building to site, and then do startup and commissioning of that. I spent a number of years just going around teaching analyzer sample system courses. We like doing that teaching piece of it, but we also think it's helped us to be quite good at kind of implementing those solutions for people. And so we will work with customers, whether it's an engineering company or an end user, right from the front end engineering design stage through detail engineering. We will provide fabrication services. We will commission and start up the system on site. And for us, service is a big part of the business. We like to be able to provide field service. All the products that we sell, we usually make sure our service people are fully factory trained on and can provide support in the field. So I'm gonna start just running through a bunch of different products that we've developed for different applications. And with some of them, there might come a little story about why it got developed. So one of them that really got us along this path was this weird chemical called dithiazine. Dithiazine is a product of scrubbing H2S, removing H2S. And so, of course, they remove H2S from natural gas. And it's commonly removed now, or very often removed, using another chemical called triazine. And when they add triazine, or they bubble the gas through liquid triazine, it converts the triazine into this chemical dithiazine that we show up here. And everybody assumed that this chemical was so big and heavy, it wouldn't end up in the natural gas. However, it was determined that it was showing up in natural gas and causing a lot of problems on natural gas transmission systems. So we had a client come to us and say, we've got this chemical in our pipeline. It's there at parts per billion levels, and we don't know how to measure it. And we looked around and we figured out, well, nobody else really knows how to measure it either. We were fortunate that Alberta has an organization called Alberta Sulfur Research Limited. And there's a lot of guys who know a lot about sulfur over there. So we were able to work with Alberta Sulfur Research actually did a bunch of development of a test method that could be done in the lab. And then we said, well, let's make that into something that we can implement out in the field. And because this chemical is there at such low concentrations, there wasn't an easy way to do it directly with an analyzer. So we developed what was called a purge and trap method. So what we do is we put a little column in here that contains a material that can absorb dithiazine. We let natural gas from the pipeline flow over that column for a period of time. Oops. Actually, sorry, just trying to don't have a second display, so I have to get some stuff out of my way. It flows over there. We have an integrating flow meter, which tells us how many liters of natural gas float over the column. The column absorbs the dithiazine. The customer sends the column back to us. We do a solvent extraction and a measurement in the lab. We tell them how much dithiazine the column absorbed. By knowing how many micrograms of dithiazine there was on the column and how much gas flow there was, we know how much parts per billion of dithiazine was in their pipeline. And so we build these panels, we ship these systems out, and we do the routine lab work. At the same time, people wanted to know, well, sometimes my regulators get plugged off at my gas turbine or whatever. And I think the stuff is dithiazine, but I don't know what it is. There's a solid material that shows up. And then one of the problems they had with it is it could plug off regulators any place there's a pressure drop. And so we also designed this or developed this solution that's a clear blue color. And you can take a sample of what's plugged off a regulator, put it in the solution, shake it up. If it turns a yellowish green color, it's dithiazine. And so again, I like talking about this project because it's one of the areas where we sort of said, yeah, we'll help you figure out how to measure this stuff that at the time nobody really had a good method for measuring it out in the field. We develop a lot of components along the sampling side of things. So how to extract samples, how to condition samples, how to protect against issues in sample systems. And so one of the things that often comes up is whether we're sampling gases or liquids, is we want to get a sample out of the pipe and we'd like to put it back into the same pipe. And of course, that can be difficult because to get flow, you need some source of differential pressure. So if there's an orifice plate or a control valve, you can sample off the highest pressure side of the orifice plate and return on the low pressure side of the orifice plate. But if you don't have any of those things available to you at the point you want to sample, your only choice typically has been to put in a pump. So what we developed was instead a sample probe that uses the kinetic energy of the flowing fluid to create differential pressure and force flow through the system. So if product is flowing along and down this pipeline, when it impacts on this scoop part, it creates a high pressure, and that forces flow out through a central tube, which can come and return back around, flow in an annulus, and return back to the process on the sides. It turns out that if we have flow hitting a cylindrical object, the highest pressure is on the front of the object and the lowest pressure is on the sides. So we use that differential pressure to drive flow. And I believe this little animation will work. I'm going to erase my ink that's on here. So, oops. Yeah, so if there's flow going down the pipe, it creates pressure at the front part of that scoop, drives flow up through a central piece of tubing, returns back in an annulus, and goes right back into the process. This can allow us to sample a high pressure fluid like natural gas and return it back to the process instead of venting it to atmosphere. And the important part of that is, of course, that people have said that methane emissions contributes to global warming. So whether you're a believer in all of that or not, people want to reduce their methane emissions. And this allows us on the natural gas side to create a fast loop that returns back to process. It also allows us to create fast loops in liquid systems, which can be used for sampling, for grab sampling, to get liquid out to a vaporizer, or when we sell some of our JP3 systems, our infrared systems, we use this method to drive continuous flow through the flow cell. Oops, there goes my animation again. So typical applications we put this in can be for closed couple analyzers. So by closed coupled, I mean analyzers that we put out right out close to the process. We put these into applications where people are trying to measure purity of hydrogen at hydrogen plants using Raman analyzers. We put this in a lot of JP3 applications where we're measuring liquid streams with near infrared. And it just creates this fast loop that returns right back to the process. It means we don't have any venting. If you're putting in something like a gas chromatograph on a liquid stream, you often want to run a fast loop out to the vaporizer. And usually there's no low pressure point to return the fast loop to. So a lot of people don't put fast loops in. And as a result, they get really slow response at their vaporizers. We can actually run the fast loop here out, return back into here, and then install a heated vaporizing regulator off the fast loop. And now we have a gas sample to go to our GC. It really improves response times. So a lot of times people can't get good control off of their process GCs because it just takes too long to get to the vaporizer. We've also used these for composites sampling and grab sampling to make sure we have fresh samples there all the time. And so most of the products I'm going to talk about, by the way, Um, there's brochures and there's ways to request information or even get quotes directly right off of our website. Again, we've had a customer that came to us and said, we've been using probes that we've had issues with them plugging off, or they were retractable probes, and the sealing mechanisms weren't always as reliable as we would like them to be. And so they said they wanted a low-cost probe that gave them really fast response. And so we manufacture these small quill probes. These typically will be on an NPT fitting. We do them normally half, 3/4 inch or 1 inch NPT. They're all machined out of one piece of stainless steel, so no welds, which helps from a integrity perspective. They don't tend to crack at welds. Um, Very narrow central bore, so they give a really fast response. We have a hemispherical tip on these, and the hemispherical tip has some real advantages. When you're flowing fluid, it has to move around the probe, and as a result, it moves at higher and higher velocities, and the highest velocity in the direction of flow is right at the tip of that hemisphere. That high velocity wants to entrain any particulate or liquid droplets that are in the pipeline and have them move along in the direction of the flow of the pipeline. If we're sampling at 90 degrees to that, it's difficult for that particle to make a 90-degree turn and go into there. So these probes tend to run extremely clean. When people saw how narrow of a bore we had in there, their immediate concern was, oh, but it's going to plug off. And we've put out probably 600 of these in natural gas applications where there's sometimes compressor oil entrained or amine entrained, and we've not had any of these plug off. And so it's a useful device, especially if you're trying to put in a fast response analyzer like a critical shutdown H2S or a critical shutdown moisture analyzer. Gives extremely fast response and provides you with a nice clean sample, tends to leave entrained fluids behind. Another small product that we make is really just a mechanical assembly that we can add on to two-way or three-way valves. And it's to make them a spring returner, what we refer to as a dead man's valve. So the idea is to use these in applications where you don't want the risk of somebody leaving the valve open. And when they do have to open the valve, they only need to open it for a short period of time. So we will often put these into grab sampling applications where we go, well, the guy's going to pull a sample. We want him to open the valve and pull the sample. But when he's done, we want to be sure he closes the valve. So with the spring return, he has to hold it open. And as soon as he lets go of it, the spring automatically closes. And the value of this is you just get rid of one potential accidental leak path. And so we use these a lot in our sample systems for valves that we might be perhaps that the valve is there so that you can vent to flare header to take the pressure off. You don't want to leave it open to the flare header in case the plant goes to flare. So this way the guy goes, if I want to vent to flare header, I open the valve, vent to flare header. When I let go, it automatically closes and I have no risk of human exposure, say, to the flare gas. Or we'll use it on grab samplers or rotometers where we say, I only want to periodically look at the flow. Most of the time, I'd like to bypass the rotometer. So again, we have clients that just come on our website and order these for sample systems they're building as well. One of the common issues that can occur in analyzer sample systems, um, It's one of the most common problems that we see oftentimes is liquids carryover in our gas phase systems. And so, uh, if we haven't done a good job of coalescing liquids or had a knockout pot, or we get into a process upset, we often see liquids come over in our gas phase systems. And if they get in our analyzers, they contaminate our analyzers. And usually we don't know we have liquids carryover until we've got a contamination issue and the analyzers stopped working. So these devices are put in line. So we have a piece of tubing, flows through the head of that device. So there's an entrance port and an exit port. Inside that device, it's been machined so that it runs kind of like a swirl filter. It makes the fluid run round and round the wall as it goes down. So the fluid comes in and starts to go into a cyclone and goes down into a little cup, basically. The high velocity as it goes around the cyclone part pushes any entrained liquid droplets to the walls. Those drain down, and you end up with liquids forming in this little cup region down here. And underneath that cup region, we have, the wires that are coming out here, is a little sensor that basically detects if there's liquid in the cup. And so it just says, you're building up liquids inside of the carryover sensor. If you keep running like this, those are going to probably get into your analyzer. So we can use the output from this to raise an alarm that there's liquids carryover, to close a valve to protect the analyzer, and we can use it to protect our assets so we don't have to do as much maintenance on the analyzers. Common applications of these are wet streams, flare gas streams, stack gas applications. But again, oftentimes we like something like this in front of our gas chromatographs. If we get liquids into those little injection valves, plugs off our GC injection valves. And again, like I say, most of these were built because of issues that customers were having in the field. Um, we also built for a client these fugitive emission panels. Um, and so a lot of times when people use lead acetate tape analyzers, especially up here in Canada, well, I shouldn't say most or all lead acetate tape analyzers usually have the gas flow over some acetic acid. And they do that to humidify the gas. The lead tape likes there to be some humidity in the gas that's coming to it. And that's fine. And then they vent these gases out the shelter, out the analyzer building. Well, of course, in Canada, where it's minus 40, if you have a wet gas going out a fitting in the analyzer building, it freezes off. So typically, these analyzers will often have a natural gas driven aspirator that dilutes the wet gas with dry natural gas before it goes out the shelter so that the vent doesn't freeze off. We were working with a client who had a number of these analyzers installed. And when they went through and evaluated their emissions from their metering buildings, they realized that the vents from all other analyzers, because CO2 is, I think it's classified as 40 times as much a greenhouse gas, or methane is 40 times as much a greenhouse gas as CO2. These analyzer vents were contributing 12,000 tons of CO2 emissions a year. And at the sort of greenhouse gas or the CO2 tax credits you can get, as our wonderful prime minister implements his plans and gets to $250 a ton or whatever, can end up being $2.3 million a year of tax on the CO2 emissions. And so they came to us and asked us to redesign how that whole thing was done to really minimize how much methane was going to go out. And so we basically designed just a far more efficient aspirator and a back pressure regulator that keeps the exit of the analyzer at constant pressure, but dramatically reduces the amount of methane emissions from the use of these analyzers. So again, like I said, a lot of the stuff that we do is sample system related. Again, a client comes to us and says, there's a new analyzer out from ABB, the Sensi Plus, and it is a very nicely done analyzer. It uses what's called cavity ring down spectroscopy to measure low levels of H2S and moisture. It's got extremely fast response, very stable. And we had a client who was going to standardize on the use of that analyzer. However, their experience was that even though the analyzer had very fast response, the sample systems they were getting provided with the analyzer didn't. And they said, we would like an analyzer sample system that's small, that's compact, that has absolute minimum chances of leakage, and gives us much faster response. And so we laid out what we would want to do in the flow path, which was, have a sample come in, go past the membrane filter. Part of it goes to the bypass side. So we have a bypass flow. The part that goes through the filter goes through a pressure regulator out to that fast responding analyzer. That Sensi Plus is going to sit over here. Return from the analyzer comes and goes to the common vent. So that was kind of the flow layout we wanted. And the analyzer doesn't have to be a Sensi Plus. We've used this on other ones, but it was specifically designed around the ABB analyzer. And so that was the layout we want. And now we have to meet the requirements of really fast response, very compact design, minimal number of connections for leakage. So we looked at standard membrane filters and redesigned the inside of the membrane filter to get much better mixing and faster response. We built this entire thing out of a machine block to get rid of all of or the majority of the tubing connections, and made very small ports inside the block so that it gave fast response. And basically, I'm going to just zoom if I can get my cursor to work here. How come my cursor's not showing up? Let me see if I can do it like this. So there's the machine sample system. You can see some lines drawn on there. They show the flow paths. It comes in, goes through that membrane filter. There's a three-way valve at the top to select between sample or calibration. The internals of that membrane filter have been designed to give the absolute fastest response possible. The entire capabilities and flow paths of that system have been machined internally into the block, with the only external component being that pressure relief valve that you see there. So that's the entire sample system. It is about yay tall, a little bit bigger than my cell phone. If it gets plugged or contaminated with, let's say, compressor oil, it's small and light. You can just grab the whole thing, take it off the wall, put another one on, take it back to the shop and clean it. So there it is mounted beside the Sensi Plus. So we made it so it fits on the same size strut separation as they use for mounting the Sensi, and mounts very close. And what they found was it made the whole system run 3 times faster. Compact. The other beauty of it is they are all identically the same. So often if you go to an integrator and you go to 2 different integrators with the same PNID, you get 2 different products built for you. we can make these exactly the same, whether it's being used in northern Alberta or being used in Malaysia. If you've got a company that spans the globe, you can use this everywhere and have exactly the same system. We did a similar thing for sample distribution. So we had a client who again said, I have to put in these metering buildings. And I end up putting this big panel with all these valves to select which analyzers I'm going to, multiple regulator stations, filtering stations, etc. And so he said, let's take that, make it compact, make it one machined device that becomes our sample metering block or distribution block. So again, we can come in at full line pressure, run through a membrane filter. Critical orifice controls how fast, how much fluid we're going to vent. Two high pressure taps. The high pressure taps might go to a hydrocarbon dew point analyzer or to one of our moisture generators. Two stages of pressure regulation. Break up the Joule-Thomson effect across two different regulators. Out to up to 4 analyzers with a 3-way valve in there so that we can zero or span each of those analyzers. Overpressure relief valve to a common vent. A second common point that they can come in. This allows them either to run a common zero to all of the analyzers or have a second metering building where they've done the pressure reductions and just send the gas over from that metering building to run to the same analyzers. It's useful when they have two pipelines running in parallel. So that's sort of a simplified P&ID of the entire system. When it's machined and put together, again, small block of aluminum about the width of your laptop, smaller than the size of a laptop screen. All of those components are there. Again, all the components are surface mount. So if you have to change a component, it's really easy. You don't have to untube things and retube things. It's 4 bolts, take the component off, put it back on again. All these fittings on the sides, we tend to try to avoid NPT fittings. We use straight threads with O-rings. They seal better, they don't gall. So very maintainable in the field. Small, compact, takes up way less wall space. And we can apply this to natural gas metering applications, to SEMS applications, any place where we're using multiple analyzers. Another product which has proven to be quite interesting and applicable, has been our moisture generators. So if you're familiar with analyzers, almost every analyzer you put in the field, there's a way to calibrate it. Put an H2S analyzer in, you buy a bottle of H2S in nitrogen, you calibrate it. Put a GC in, you buy a calibration standard. Most of the moisture analyzers that are out there in the field don't get calibrated or validated. And the reason is there's not been a good way to do it. You can buy over a minimal certain concentration range, you can buy moisture cylinders, calibration cylinders, but they're very difficult to, they're not stable usually. They tend to drift the amount of moisture absorbs on the surface. Um, so they're not very reliable. Cylinders are hard to transport around with you if you want to bring them out with you in the field. If you're doing very low levels of moisture, you can't put those in the cylinder because they don't work. So if you've got like a mole-sieve dehydration unit, and you're trying to measure on that 0 to 5 part per million range, there's no way to field validate these devices, or there hasn't been historically. And so what we set out to do was to create an all mechanical device. So we didn't have to worry about electrical hazardous area certifications that you could take out in the field with you and use to validate a moisture analyzer. So the way it works is like this. We have a high pressure gas. Something like natural gas, maybe it's at 60 bar. 6,000 kPa. We bring that into a pressure regulator and we regulate the pressure. We can set it to different values. I'm going to use, for an example, we set the regulator to 1,000 kPa. Inside this block of metal, there's a moisture saturator. So it's just something that can basically make the gas wet. If we know the temperature of the block, I'm going to assume it's 20 degrees C. I get 2.3 kPa of water vapor. This is happening at the high pressure. There's a critical orifice here to control the flow rate. So if I have 2.3 kPa in 1,000, it's 0.23%. At the same time, I'm taking that high pressure gas, going across another critical orifice, and it runs through a dryer. So it produces a stream of dry gas. So the upper part there produces a stream of wet gas. The lower stream produces a stream of dry gas. If I keep this valve closed, I can run dry gas to my analyzer and check zero. This gas, my wet gas will come in and mix with the dry gas. If I know the ratio of the two orifices, let's say for every 1 unit of flow I get through this orifice, I get 20 times as much flow through that orifice. I would dilute the gas 20 to 1. So 0.23% divided by 20 is going to be around 0.0115%, or 115 parts per million. So by knowing the pressure that I've set the regulator at and the temperature the block is running at, assuming that the block comes to me with a calibrated dilution ratio, I can generate a known concentration of water vapor. Not only that, if I want to generate a different concentration of water vapor, if I took the pressure up to 200 kPa, the water vapor would drop to to half of this, 0.56 bs. 0.56. Or 56 ppm, approximately 57 and a half. So I can use this device now in the field to check the zero on my analyzer and to check what it reads at a couple of different points. It's worked so well that we've had customers come to us now and say, well, I don't want to use it for field calibration. I want to build it into my analyzer shelter. I want to put it in a temperature controlled box, put a pressure controller in front of it, so I can adjust the temperatures and the pressures and generate any concentration of water vapor I want. And so to give you an idea, the way it works is if you run it at different temperatures or different pressures, you get different water contents. So I show 3 curves up here. This is for a relatively high range block. Show it at 20 degrees C, 30 degrees C, and 40 degrees C, and different pressures. So if I ran at 20 degrees C and I ran it at 800 PSI, I would generate around 25 parts per million. But if I ran it at 200 PSI and 20 degrees C, I'd generate around 100 parts per million. So like I say, I can change the pressure and change the water content. We make the blocks in three different ranges, or the generators in three different ranges. 0 to 100 is very useful for natural gas pipelines because it corresponds to around the range that you want to measure in a natural gas pipeline. 0 to 50, 0 to 60 is very useful for instrument air dryers, and 0 to 5 for things like processes that have molecular sieve dehydrators. And so we build these blocks on each range, and they can provide accurate calibration or validation of each range. This graph just shows an example of what we get from a moisture generator as we change the pressure again. So we took a 0 to 5, sort of 0 to 6 ppm moisture generator. When we were running it at high pressures, so the red line over here is pressure, we're at about 1,000 pounds, we were getting a little bit less than 1 part per million. And then what we did is we just let the pressure slowly bleed down through the block. And as the pressure drops, the water concentration goes up. The black X's are what we measured on a Tiger Optics cavity ring down spectrometer measuring moisture. The red line over here is what we expected from our calculations. So there's a bit of deviation, and it could be, was the analyzer calibrated properly? Is our equation of state perfect? No. We tell people this is about a plus or minus 5% of reading accuracy measurement. But it's sufficient to prove that my analyzer is linear, because I can say, well, I did the measurement at 2 or 3 different concentrations, and it agreed with what it should do. It's sufficient to tell us when my analyzer responds to a change in moisture concentration. And if I run this every week, I can say, well, is the analyzer running the same way it ran last week? So it tells me whether I need to do maintenance on my analyzers. So again, we're seeing this get used a lot in natural gas applications, in refining and petrochemical applications, carbon capture pipelines. It's an interesting little product for a lot of people. And again, I'm just trying to get people aware of that it's actually out there and we can do this. We do a lot of sampling applications as well, automated sampling. So on the liquid side, things like crude oil or natural gas liquids, there will often be what people call a lease activated custody transfer skid, a LACT unit. And by custody transfer, they mean, well, the person on one side of the fence is the producer of natural gas or of natural gas liquids, let's say condensate. And on my side of the fence, I'm the pipeline company. I buy the stuff off of them. I want to know, on average, did he give me the product I want? So what they do is they do a flow weighted average, and they have this big accumulator vessel. This might be 15 liters or so. And there's a little pump, and every 10 barrels of crude oil or condensate that goes by, it'll do an injection into this vessel of about 1 milliliter. And over a week or a month, it fills that vessel up. So the fluid that is in that vessel is a flow weighted average of what was produced at the plant. And then what they do is they take a sample of that fluid, fill up a sample cylinder like the one over here, and they can take that sample to the lab and get it analyzed. And this is a common mechanism that's used in the custody transfer of both natural gas in the gas phase and in liquid phase. And so we had a client that came to us and said, Canada, we have specific requirements for CRN. And they said, look, we'd like you to design us a, a composite sampler that has full CRNs, that's customizable, and you can use it in different applications. So we went through the entire design. They're one of the largest pipeline companies in Canada, and this is now their standard. So we design and build custody transfer systems around composite samplers. I like to point out too, we like to do things like color code valve handles. When you're going to write a procedure like is there in the middle and tell people how to pull a sample off of it, color coded valve handles just make it easy for people to follow procedures. So again, we'll do these sort of samplers for condensate, for crude oil. We'll build entire buildings around them. They are all API 8.2 compliant. API, American Petroleum Institute, API 8.2 talks about how to properly pull a composite sample. So we make sure that we build it to meet all the requirements of API 8.2, and we've put these out for crude oil, for natural gas condensate, for spec propane being loaded onto ships. Um, and we're happy to customize them to meet specific application needs for anybody's application. Composite samples are a time-weighted or a flow-weighted sample over a long period of time. Sometimes people want to take spot samples or grab samples. So grab sampling is often a method that is used to demonstrate compliance. So got Dale on the line here. If Dale is selling me crude oil and we've agreed to a specification that his crude oil won't have a vapor pressure of more than 100 kPa, the way I'll validate that sometimes is I'll go out and I'll pull a sample. I'll send that to the lab. I'll get it analyzed. And then I'll tell Dale, well, you were on spec or off spec. That frequently requires that there has to be a person there to pull the sample. So Dale, being the unethical person that he is, uh,
I was
um,
I was waiting for that, Phil.
yeah, you knew it was coming, right?
Yeah.
He knows I'm not going to be out there at nighttime to pull a sample of his crude oil. So he goes, well, at crude oil, at nighttime, I'll produce all the awful stuff that he wouldn't really want in his pipeline. And I know he probably won't catch me because he doesn't pull samples out there. So we've had clients come to us and say, can you build us automated grab samplers? We'll also put automated grab samplers in conjunction with analyzers. So on this particular panel over here, we have a JP3 infrared cell, and it's measuring the properties of the crude oil. And if it sees off-spec product, it can trigger and say, well, I'll fill up one of these sampling cylinders over here um, to over here, there's 4 sample cylinders waiting to be filled. And if the analyzer sees off-spec product or product that it doesn't understand what it is, it can trigger the PLC and tell the PLC to fill up a cylinder. And so we'll automate these grab sampling stations. Has a number of advantages. You can pull a sample whenever you want. People often like to pull grab samples if there's a process upset. Well, who do they send out? The operator. Well, the operator should be trying to get the process back into control. So now the operator can just push a button that triggers the PLC. PLC pulls the sample. Having the sampling under PLC control means that the sample gets pulled exactly the same way every time. Different operators will pull samples differently and can bias results. Saw something come up in the chat, but it looks like it was AI note taker talking. Yep. The other thing is it means that we have less need for people to physically handle the samples. So if you're sampling something like condensate, it tends to have a lot of benzene in it. Benzene's a carcinogen. Automating the sampling process minimizes human risk and exposure. So we have automated floating piston cylinders like this. We've automated glycol displacement cylinders. So at the top here is, let me zoom again, I guess. These sorts of cylinders that look like the sort of bottles that you usually have in the laboratory, middle ones in the lab, glycol displacement. When the valve gets actuated to take a sample, it pushes process fluid into the bottle, which displaces the glycol that's there. But by having that, can keep the whole thing under pressure, so you don't get any bubbles. So we'll automate glycol displacement cylinders. We'll automate floating piston cylinders, like I showed on the last page. We've done some now recently. We've just done a couple projects for ExxonMobil where they wanted to sample less volatile fluids, but some of them had to be protected from any exposure to air. So we'll automate sample to cup type things, but so by sample to cup, I mean sampling in an open bottle, but it stays in a closed bottle until there's an operator there. So we've automated almost every type of grab sampling station there is. We'll put them all under PLC control, which means you get lots of chain of custody information. You can see whether bottles have been filled or if you had a failed sample, error messages. We can keep track of what pressures and temperatures were in the process at the time the sample was being taken. We get accurate date and time stamps. One of the problems that happens with grab sampling in refineries sometimes is if I'm the technician and I'm walking my rounds, I'm supposed to pull a 2 a.m. sample off the dehydration tower, and it's 1:30. So I go and I pull my sample, and I write it down as my 2 a.m. sample. Well, now if they try to go, well, how is the tower running at 2 a.m.? And does that sample seem correct? It doesn't match up because the times are wrong. So when we control it all in the PLC, we get very accurate time stamping, pressure, temperature stamping, etc. Think that's going to be getting close to 1 o'clock. So auto sampling applications, we've doing it for grab sampling NGLs. We've done it for truck and rail loading. We've done them for crude oil sampling during blending operations. Especially useful when you're trying to take difficult samples, things that are dangerous, like rich in lean amine, or at high pressures, rich glycol, or high temperatures, bitumens, raffinates. And we can use these with any analyzer, like a infrared, like the JP3, a Raman analyzer, and use it to grab samples to help us to build models. So that kind of wraps me up on some of the products I want to talk about. I just wanted to give you an overview of the sort of things that Insight does, along with selling equipment like JP3, XREL, ZGAS. We do a lot of custom sample system design. And so if you have an application, we may have already done it, or if we haven't already done it, we may be very interested in trying to help you build a solution to be able to do it. Well, that kind of wraps me up as usual. Um, we're always interested in people talking to us about applications. Um, we have a whole YouTube channel that talks about a lot of the things that we've done. Our website, we update regularly with application information, and you can always just send an email or give a call to the sales group, and we'll try to get back to you right away. Thanks everybody for your time, and if there's any questions, happy to try to address them. And if not, I will let everybody go and wish you all a very Merry Christmas. And hopefully, yeah, my pleasure. Thanks, Jonathan. Pretty much love having you guys come and just let you give people an overview of what we do.
Hey, Phil, I got a quick question for you if you got a second.
Yeah, for sure.
You had mentioned the dithiazine in the sweetening process. Do you offer any kind of sample system that helps remove it or filter it out in any way so it doesn't plug the regulators?
We haven't yet. We've talked to some people about that.
Oh, okay.
I mean, you can just if you do put a filter in front of those regulators, like a big filter, it
Yeah.
will tend to pick up the dithiazine there. But you still have the problem that when you go across, it's the Joule Thomson effect as you drop pressure across the regulator.
Yeah.
We thought about um, we thought about a few things. Dithiazine's kind of basic. So we thought, if you were to take the gas and you could bubble it through phosphoric acid and it's going to take all the dithiazine out. But then people go, well, I don't know if I want to have phosphoric acid out there. Um, but one of the ways to remove it is with solvents. You could probably use the chemical that we use to make the columns that grab it, um,
Yeah.
which I think it's a divinyl styrene benzene, but it's a plastic.
Okay,
They
so
use it to make
it'd be a
GC columns.
solid.
Pardon me?
It'd be a solid then in
Yeah.
a. Okay.
Yep. And if you were to fill up like a drum with that stuff and have the gas flow through that drum, it would tend to probably pick up all of the dithiazine that's there.
Yeah. Okay.
Yeah.
And does that stuff affect other components? Like, would it strip some of your H2S or any other gas
It,
components
it
out?
it strips some of the heavier hydrocarbons as well. So it would strip some of the stuff like benzenes and stuff like that,
Yeah.
but it wouldn't probably really affect your BTU. I don't
Okay.
think it takes out much H2S.
Okay. Good to know. Thanks.
Yeah. Yep. Cool. Well, all right, everybody. I think I'll wrap this up. And again, thanks for your time. And if any questions come up, you can always feel free to email the sales guys or email me. Um, and say, have a great holiday. Those of you that you know me, the place is usually open and come by and have a beer if you want before Christmas. We always like doing shop tours as well. So if you don't know me, um, reach out and we're happy to give you a tour of the shop.
Thanks, Phil.
All right. Take care, guys.